In a bus-based system, all memory is equally accessible to all processors. That is, it's as far away from one processor as it is from another processor. That's not true on a distributed memory machine. So the question arises, where should memory be placed? Specifically, which memory addresses should be placed in which module? As we saw, the memory is distributed among the various processor cache memory modules. There are two main alternatives. The first is block interleaving, where the first block of memory would be placed in the first processor, second block of memory in the second processor, and so forth. The problem with this is that any array of reasonable size would straddle various processors and make it very hard to exploit spatial locality because you'd be doing non-local references for many of the elements of the array. The alternative to that is not to use interleaving at all, and just to locate the first 2 to the m memory words in the first memory module, the second 2 to the m memory words in the second memory module, and so forth. This means that addresses that are nearby each other are likely to be located in the same memory module, and that makes the locality a lot better for most programs. Now, the operating system is responsible for bringing in memory from secondary storage and putting it in main memory or allocating main memory. The operating system needs to be involved in the decision of where to allocate a page, even on a uniprocessor, where pages are usually replaced using some variant of the LRU algorithm, least recently used algorithm, so that the page that's thrown out is one that has not been used recently, and we can use the page frame that it occupied to allocate the new memory. Often a variant like the clock algorithm is used because LRU is very hard to implement on a system with a lot of page frames. In a non-distributed system, it doesn't matter which page is placed in which page frame because all of the memory is equally distant from the processor. But on a multiprocessor, locality matters. It matters that we have memory located to the process that's using it. One way of allocating memory so the processes that use it are close to the memory is the first touch policy. This says that you allocate memory in the memory module of the processor that first accesses it, because that processor is more likely than other processors to access it in the future. But this doesn't work too well for many parallel algorithms. If the compiler does not parallelize the initialization loop, then it tends to allocate all of the memory in one memory module, and that means that the other processors that are referring to it all have to do expensive non-local addresses, plus there may be contention for that memory module, which leads to extremely bad behavior. An alternative allocation policy that often works well is the round-robin policy, where you take each piece of memory, each page of memory, and allocate it in the next memory from where the previous page was allocated so that the memory is evenly distributed around the system.